4-2, day 2. Moving right along. Not much left. So, number 1, what is the graph of this? Now that might strike you as, wait a minute, we've been doing that. But there's a little trick that's kind of interesting if you want to really think about it a lot, but here it comes. First of all, vertical asymptotes, hopefully by now you're like, all I got to worry about is that denominator. So 3x minus 4 equals 0. We're finding out what value x can't be. So we add 4 divided by 3, we get x is 4/3, which is 1 1/3. So I can, and it does say to graph it. So we've got to identify our vertical asymptotes to get started. So 1 1/3 to the best of my ability, right there. So x equals 1 1/3. There's one of my, that's the only vertical asymptote. Now here comes something awfully strange. I'm not going to bore you with a ton of like putting stuff in a calculator. But for the first time, I want you to think about 2x plus 1 all over 3x minus 4. Now, not very often in math will you ever be allowed to do this, but all of a sudden they kind of opened a door up to it. They want you to get close on the vertical asymptote. So they're going to say, all right, how do you do that? Well, if you plugged in a million numbers for x, like if you made a table like this, you know, like -10, -9, -8, -7, -6, and you just kept going, this portion would not change the answers for y very much at all. So this is an approximation trick. So we get rid of that business. We look at this business and we say, hey, that equals f of x. Don't forget what f of x stands for. That's y. So y equals, and look at this little trick. The x's disappear. 2/3. Sorry about the mess. So my horizontal asymptote is up 2/3 of the way, and there it is. And remember, the parent function of this is 1 over x, so it just got moved. You know, it's kind of like moving the crosshairs for you, so we know it's going to look something like that. So a little bit of a trick, but it works. But that's an approximation, so that should have like little squiggly lines because it's not perfect. It's going to be a tiny bit above or a tiny bit below, but good enough. All right, you don't hear that very much in math. All right, next problem is a story problem. I've grabbed it. If you want to open up your textbooks, just to kind of see how it's presented to you, it's kind of whittled it down, filtered the information a little bit. But the idea is there's this company, and they want to go out and remove pollutants. So they give you this function, and they tell you this, which is y. That's the cost to go out and remove pollutants from whatever, rivers, lakes, not sure. But then P, this guy and this guy, is the percent removal of pollutant. Now, to make that make sense, because this equals y, I know this is going to be my cost right here, and my x is going to actually be percent removal. Transitioning this to x and y is going to help us use decimals. So when we plug this in, we're going to use x, and we're going to use x, because the percent removal is going to come from my x-axis. You can't type in the letter P in decimals. It's not going to understand that. So here we go. So the first thing we're going to do is look at the question. What percent of pollutant can be removed? So that means find x if we pay 78.3 million. You know what that's saying? If f of p is the cost, which is y, we're saying let y equal 78.3 million. We're going to piggyback this and say, hey, let's graph that. So 70, I'm just, you know, this y-axis is huge, but I'm just going to say the graph of that is 78.3. Okay, I'm not going to transition that into like, you know, 7 comma 830 100,000. So we're just going to consider this to be millions. Then we're going to go to Desmos, and we're going to type this in, and we're going to look at what this function does. I've already done that. I'm going to cheat a little bit, and it comes in like this, and it goes through 0, 0. It kind of goes like this, and it shoots up. And if you put there's a little dot there, and you can just hide your cursor over it or bring your cursor over the top, and that comes out. That point right there is 90, comma 78.3. Remember, it's $78.3 million we're spending, so that makes sense. But they want to know the percent removal, which means find x. Well, guess what? X is 90. So it costs $78.3 million to remove 90% of the pollutants. That's kind of a cool problem. Call me a nerd. One more of those. Okay, last example on your pre-lesson for day 2. And I haven't said something yet, and I want to make sure I say it, okay? Because I know I've said decimals, 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 use decimals, decimals. But if you're on a test or quiz or SAT, ACT, and it's a non-calculator, non-decimals portion, you should be able to find your vertical asymptote and your horizontal asymptote without the need of a calculator, okay? Graphing calculator or decimals. Where do we find my vertical asymptote? Always from the denominator. Notice they gave you a difference of 2 squares up there, maybe to draw your attention. Oh, I'm going to factor that. Vertical asymptote is all about the denominator. So I'm going to say x squared plus 2x minus 15 is 0. They're being nice to us by giving us nice factorable trinomials. So x equals -5 or x equals 3. These are that's what x can't be, remember. So I go to -5, 1, 2, 3, 4, 5. Should have given myself more space. X can't be 3, 1, 2, 3. So our graph cannot cross those barriers. Okay. Then our horizontal asymptote, we're going to use that wonky little trick. We're going to take 4x squared minus 9. We're going to go x squared plus 2x minus 15. And we know that equals f of x. So we're going to make that equal to y. And this is a very sketchy trick. We're going to take that off and that off because really they don't have a whole lot to do with it. But then when you do that, you got to make the squigglies. And then the x squareds cancel, and we get y is approximately 4. Now, if I thought where is y equal 4, I would go 1, 2, 3, 4, and I would make a dotted line right there. So you should be able to do that without the help of decimals. Now, how would you graph this without decimals? Oh my goodness, good luck on that. So we got to have that to help us. Technology is our friend in that situation. And I already did that. And it goes like this, up in that portion. And it goes like this, into that portion. And then in the middle, kind of does one of these things. It's kind of weird. It just kind of goes up like this, and it comes down. So go ahead and use decimals. So there's the graph, all right? The main thing in that one is really not, can I use decimals? That you should. It's really right here. Do you understand how to do the math to get a really close picture of the vertical asymptotes and the horizontal asymptotes? All right, there's your pre-lesson.